In this video, we continue our discussion, what is normal? Specifically, we will consider additional examples with the standard normal curve. Recall our setup from before. Suppose the price of gas is normally distributed with an average of $2.25 per gallon and a standard deviation of 7 cents per gallon. Part A. Half of consumers pay what price or less? Alternatively, if we're talking about half of consumers and what price they pay, we can ask the question, 50% of consumers pay what price or less? This is equivalent to asking, however, what price marks the 50th percentile? Now, since the price of gas is assumed to be normally distributed, we could draw a normal curve to represent what is going on, and we know that the average price is $2.25. And to the left of this, by properties of the normal curves, represents 50% of the area total beneath the curve. So, to answer the question, what price marks the 50th percentile, is a fairly straightforward one to do with this. We observe that 50% of consumers pay $2.25 or less for their gas. So the answer to this part is $2.25 per gallon. Answering the next part to this question, however, is not so obvious. Consider part B. 75% of consumers pay what price or less? Alternatively, that's the same as asking what price marks the 75th percentile. To answer this part of the question, we will use the normal curve, but we will work backwards. So again, we assume that the price of gas is normally distributed, so we'll go ahead and draw our normal curve, and that the average is $2.25. If we want to know what price marks the 75th percentile, we really want to know what is this price here to the right of the average, such that 75% of the area is what we have shaded here. Again, recall that to the left of the average will represent 50% of the area. So really we want to identify what price here corresponds to having 25% of the area represented to the right, or in this portion that we have. So here we know the area, 25%, but we don't know the z-score, or we don't know how many standard deviations above the average this price is. So now we want to know the z-score corresponding to an area of 25%. So we're going to pull up our table for the standard normal curve, and we're going to look at the columns associated with area. So again, that's the right column of the two as they're paired together. And I'm going to look for a number close to 0.25. Notice that there are two values that are relatively close to 0.25. Let's write both of those down in our example and determine which one we should use. So we're going to have an area of 0.252 has a corresponding z-score of 0.68, and an area of 0.249 or 24.9% has a z-score corresponding z-score of 0.67. So we have that copied down here. Now, which one of these do we want to use? Which of these areas should we use? We're actually going to go with the one on the right here because this is closer to 0.25 or closer to 25%. So we'll go with this area right here. Okay, so we're going to work with a z-score of 0.67, but what exactly does that mean for us? We want to know now what price is 0.67 standard deviations above the mean. In other words, the z-score of what price gives us 0.67. At least the first time, let's recall the formula for how we calculate the z-score of a value. The z-score of our price in question is given by take the price in question, subtract from it the mean, divide by the standard deviation, and I want to get 0.67. So if we were to solve this equation, the next step would be the price minus the average is equal to 0.67 times the standard deviation. Adding the mean to both sides, we have our price in question is equal to our average plus 0.67 standard deviations. Plugging in our specific values of $2.25 for the average and 7 cents for our standard deviations, we obtain the following for our answer. What we actually get is $2.29, 0.69 cents, but that we can round to $2.30 per gallon. So in answering the question, what price marks the 75th percentile, that would be $2.30 per gallon is going to mark the 75th percentile, or 75% of consumers pay that price or less. It's important to note at this point that when we're talking about the 75th percentile, that's the same thing as talking about the third quartile. And we frequently ask questions such as, what price marks the third quartile, or what price marks the first quartile, or 25th percentile? So it's useful to actually learn how to find the quartiles, and the fact that the z-score of 0.67 will be fairly consistent. In general, you can use the following formulas to identify the quartiles. Recall that the second quartile is really the 50th percentile. Well, that's going to be given by your average price, or your average height, your average weight. That's given by the average. As we saw in the second part to this problem, part B, to identify the third quartile is the same thing as identifying the 75th percentile, and that price, or height, weight, whatever, will be 0.67 standard deviations above the mean. So that's going to be your average plus 0.67 standard deviations. To identify your first quartile, or the 25th percentile, think of the fact that we could use symmetry and say, well, the 25th percentile will be 0.67 standard deviations below the mean. So you'll take your mean, and from that you subtract 0.67 standard deviation. These formulas then partition, in our example, our price up into the quartiles, the first, second, and third quartiles. Let us now consider some other parts to this example. Let's consider part C. What price marks the 20th percentile? So again, when we're asking about percentiles or quartiles and trying to figure out the price that marks that, we're going to start by drawing our normal curve associated with the example. So here's our normal curve, average of $2.25 per gallon. And if I want to know what price marks the 20th percentile, I want to know this price right here along my horizontal axis. What price would contain 20% beneath that value? And since 50% has to happen in the left half of my normal curve, that leaves an area of 30% for right here. Now when we go to use our table, we're not going to look up the area associated with 20%, because recall that our table measures the area between your average and a specific z-value. So instead we're going to look up an area of 20% and then determine the z-score for the price that we have in question right here. So pulling out our table, remember that the columns come in pairs. We're going to be looking at the column on the right to try to identify where we encounter an area of 30%, or rather 0.300. We found it right here in this column. An area of 0.300, or 30%, corresponds to a z-value of 0.84. Let's go ahead and record that on our piece of paper. So now we ask the question, what price is 0.84 standard deviations below the average? To identify this price, we're going to consider our average, and from that we subtract 0.84 standard deviations, or plugging in the average of 225 and the standard deviation. We obtain a price of $2.1912, or rounding that approximately $2.19 per gallon. So it'd be fair to say that 20% of people pay $2.19 or less for the price of gas. Let us now consider part D to this problem. What price marks the 90th percentile? Again, start by drawing our standard normal curve, or rather in this case, just our normal curve, and we indicate that our average is $2.25. If I want to know what price marks the 90th percentile, then I want to know what price has 90% of the area at that point or less, or below it. So I'm really looking at having 90% of the area. It's going to look something like this. Recall that 50% of the area, again, happens to the left of the average. So I want to look at what price, along my horizontal axis, corresponds to an area of 40%. Pulling out our standard normal curve table, we again look for our area column to find the value of 40% of area and see that it corresponds to a z-score value of 0.28. Recall what the z-score represents. The z-score represents the number of standard deviations that value along the horizontal axis is above or below the mean. So again, an area of 40% or 0.400 corresponds to a z-value of 1.28. So at this point we ask ourselves the question, what price is 1.28 standard deviations above the mean? Translating this question to a formula, we have what price is equal to my average plus 1.28 standard deviations. And we can again plug in our specific values and obtain the following. We get $2.33 and 0.96 cents, or rounding $2.34 per gallon. This price, if you were to look for its z-score, check its z-score, you would get that it sits 1.28 standard deviations above the mean, or in other words, taking the z-score and looking it up in the standard normal table, that means that there's an area of 40% between our mean and that price, and if we add together the 50%, we get a total area of 90% beneath, or in other words, this represents the 90th percentile, or 90% of people pay this price or less for their gas. In general, if we're trying to identify the value that is, say, n standard deviations above the mean, we will use the formula. That value will be equal to your average plus n standard deviations. If we wanted to find a value that is n standard deviations below the mean, we use a similar formula, and that value will be equal to your average minus n standard deviations. Now, where do we get this value of n? How do we know how many standard deviations we want to go above or below the mean? That's coming from your z-score. Now, where do you get this z-score? You identify the area that you want to work with in the problem, you look that up in your chart, and you work your way backwards to a z-score. And that z-score value, that's going to be the number of standard deviations, n, you want to be either above or below the mean.